All right, welcome. I want to discuss some special terminology that we use for matrices that have some special properties. So the first term that I'd like to define is what we mean by a square matrix. So sometimes we have matrices like this one over here, which has 2 rows and 4 columns. So the number of rows and the number of columns are different, and the matrix is a rectangle that's not a square. So this would be an example of the matrix which is not a square. But when we have a matrix which has this nice property that it has the same number of rows and columns, then we call it a square matrix for obvious reasons that the matrix is shaped like a square. So here is a case that we have a 4 by 4 matrix. We have 4 rows and 4 columns. So this would be an example of a square matrix. And when we're talking about a square matrix, we have diagonal entries. So that would be the entries that are on the diagonal. So that would be 1, 6, 11, and 16. We would call these the diagonal entries, and everything else would be considered an off-diagonal entry. So these diagonal entries I've boxed in black, 1, 6, 11, and 16. These would be the diagonals, and everything else is an off-diagonal. For matrices that are not square, we don't have this notion of diagonal and off-diagonal because there is no single diagonal. So this terminology of diagonal, off-diagonal, non-diagonal, that refers only to square matrices. And again, a square matrix is a matrix that has the same number of rows as columns. And then we have a very special type of square matrix, which is called an identity matrix. So the identity matrix comes in different sizes, but it is a square matrix, first of all, such that all of the diagonal values are equal to 1, and all of the off-diagonal or non-diagonal entries are equal to 0. So what I've written over here, I2, this is the 2 by 2 identity matrix. So this is a 2 by 2 matrix, which has 1s on the diagonal and 0s off the diagonal. I3 is a 3 by 3 identity matrix that has 3 1s on the 3 diagonal entries, and all of the off diagonal entries are 0. And you could have I4, I5, I6, and so on. So any square matrix that has all 1s on the diagonal and all 0s off the diagonal, that is what we consider the identity matrix. And we call it the identity matrix because it has similar properties to the number 1, such as like when I take any number and I multiply it by 1, I get that number back. And we'll see when we define matrix multiplication, this identity matrix is very similar. If I multiply a matrix by the identity matrix, it doesn't change the matrix. We get the same matrix back. So that's why we use this terminology for the identity, because it works very similar to the number 1. The last thing I want to mention in this video is how we can create the identity matrix in R. And so there is a nice function called diag, D-I-A-G, and all I do is I indicate the dimension of the identity matrix that I want to create. So if I do diag 3, this creates a diagonal matrix, the 3 by 3 identity matrix. If I did diag 4, I get a 4 by 4 diagonal matrix. Could do diag 10. This gives me the 10 by 10 identity matrix, I10. So that is a nice way of entering the identity matrix without having to enter every single value individually, as we've been doing with some of these other commands with the matrix. So this just creates an identity matrix for us in a really nice way. We just need to indicate the size of the matrix, and it will create the rest of the matrix. Okay, great. So next up, in the next video, we'll get into how we can index and subset matrices.